in this video, we're going to talk about pathway problems. So we're going to talk about two classical types of pathway problems. The first one is a 2D pathway problem, while the second one is a 3D pathway problem. So for all the pathway problems, we can all use either manual method or combinatorics approach. So let's look at how we can approach this particular example right here with manual method. So the general rules is simple. We have a grid here, and we start from the point A, which is on the left top corner, and we are trying to move to B, which is on the right bottom corner. And we can only move either down or right. So we must keep moving towards B. We need to move closer and closer to B. So our way is to see how many ways can we go from A to this point right here. There's only one way. What about here? There's only one way as well. And what about this point right here? How many ways can we go from A to here? It's still one. So all the points that's vertical, directly vertical from A and horizontal from A, which are the two directions that we can go for this particular question, are all one. And then we just add these two and we will get this number. Add these two, we will get that diagonal number. And we do the same process, so on and so forth. And we will get something like this. 4, 10, 20, 35, 56, 84. We just keep doing this process. And eventually, we will arrive at that answer. So we'll see something like this, and at the end, we will have 264, 462. So this is what we'll get from a manual perspective. If it's combinatorics, how can we think about this? We go from A to B, we need to move 5 steps to the right, and then 6 steps down. So how we can do this is that we can imagine we are permutating these things right here. So it's essentially a 5 plus 6 factorial, and we have 5 same objects and 6 same items, and these should equal to each other. And for a 3D pathway problems, it will be kind of hard to do it manually because we need to consider so many different perspectives. Like if we have a square, like this, and then we will find that if we want to find this point number, we need to add this one, we need to add this 2 and 3 numbers together, so which is not really convenient for us. So what we can do is that we can directly approach it with combinatorics. So for example, in this case, we can only move right, up, or this direction. So we need to always move closer to B. So we have 4 steps to the right, 4 steps up, and then 2 steps inwards. Therefore, in total, the permutation of all of these arrows, these possible steps that we can do, is 4 plus 4 plus 2 factorial divided by 4 same items, 4 same items, and 2 same items. So essentially, we're finding all the possible permutations of these steps. So this is how we can approach these kind of pathway problems. Thank you so much for watching.